Hi everyone, in this video I am going to explain applications of equilibrium constant K and degree of dissociation alpha and relationship between delta G and K. Okay, in this first applications of K, applications of equilibrium constant K. When K value increases, equilibrium constant K value increases, the stability of product increases. The stability of product in equilibrium reaction increases, and stability of reactant decreases. Stability of reactant increases and stability of product increases, stability of reactant decreases. As equilibrium constant K value increases, stability of product in equilibrium reaction increases and stability of reactant decreases. So if you see example, XO gas dissociate to give X2 gas plus O2 gas. Consider for this equilibrium constant K1, that is 1.0 into 10 power 24. Consider second equation. This is equation 1. For second equation, here gas is dioxide gas. It dissociate to give X2 gas plus 2 moles of O2 gas. For this equilibrium constant K2 is equal to 2.5 into 10 power 10. If you compare K1 and K2, K1 is 1.0 into 10 power 24, K2 is 2.5 into 10 power 10. Which is greater value? K1 is greater than K2. K1 is greater than K2 because it is 10 power 24, it is 10 power only 10. Then what we can say? Stability of, if you want to talk about stability of oxide, stability of XO less than stability of XO2. So here first equation, equilibrium constant is greater, its reactant stability is lesser. For first equation, equilibrium constant is greater, stability of its reactant is lesser. That is my point. Next, second one, degree of dissociation. Degree of dissociation is what? It is the fraction of, the degree of dissociation is, it is the fraction of moles of reactant molecules dissociated. For example, if number of moles of reactant taken initially A, see this, degree of dissociation alpha is equals to X by A. Degree of dissociation is equals to formula X by A. So what is alpha? Degree of dissociation. Then what is X? X is number of moles of reactant dissociated. number of moles of reactant dissociated. And what is A? Number of moles of reactant taken initially. Okay, so the maximum value of alpha is 1, because if 10 molecules taken initially, 10 molecules are dissociated, 10 by 10 become maximum 1 only. The alpha percentage is, maximum value of alpha percentage is 100. Okay, so degree of dissociation is a ratio between number of moles of reactant molecules dissociated to number of moles of molecule taken initially. Next, factors affecting on degree of dissociation. Factors affecting on degree of dissociation. First is addition of inert gas. Addition of inert gas. Addition of inert gas. So when inert gas is added to equilibrium reaction, suppose this is a vessel in which reaction taking place, reactant gives rise to product, and this is the reaction which is present at equilibrium state. Now it has reactant molecules and also product molecule. Now what happened? Inert gas is added. Inert gas, addition of inert gas to what? Equilibrium reaction. Then degree of dissociation will, by the addition of inert gas to equilibrium reaction at constant volume and temperature, alpha will become. So by the addition of inert gas to equilibrium reaction, number of gaseous molecules increases in the vessel. So already reactant gas is there and product gas is there. Reactant gas molecules are there in the vessel and product gas molecules are there in the vessel. By the addition of inert gas, what happens? Number of gaseous molecules will increase in the vessel. Then what happens? Partial pressure of reactant doesn't change. Partial pressure of reactant doesn't change. It's a constant. Partial pressure of reactant constant. Partial pressure of product also constant. But total pressure increases. Whenever number of gaseous molecules increases, P total increases. Total pressure increases. Total pressure increases. That means by the addition of inert gas to equilibrium reaction at constant pressure and constant volume and temperature, total pressure increases. That is my point. P total increases. P total increases. But partial pressures, individual pressure of reactant, individual pressure of product, partial pressures of reactant and products do not change. Partial pressure of reactants, products do not change. And molar concentrations also. Molar concentrations of reactants and products. Molar concentrations of reactants and products do not change. So remember, by the addition of inert gas to equilibrium reaction at constant volume and temperature, volume constant, temperature constant, then what happen? Partial pressures of reactant, partial pressure of product constant, do not change, but total pressure increases. As the number of gaseous particles increases in the vessel, number of collisions increases, total pressure increases. So partial pressures doesn't change. Partial pressure of reactant, partial pressure of product do not change, means alpha remains same. Alpha remains same, as partial pressure of reactant do not change, partial pressure of product do not change, molar concentration do not change, alpha remains same, because alpha depends on molar concentration of reactant and partial pressures of reactant only. That is my point. Next, volume effect. So the effect of volume on degree of dissociation, alpha, alpha is equals to what? X by A. If initial number of moles are same, alpha proportional to what? X. So for proportionality, I can use alpha or X, both become same. So alpha proportional to or X proportional to, alpha proportional to X proportional to, both become same. V power delta N by number of moles of gaseous product. This is important. So what is effect of volume on X? Number of molecules, number of moles of reactant molecules dissociated, number of moles of molecule dissociated proportional to volume of the reaction mixture power delta N, number of moles of gaseous product minus number of moles of gaseous reactant, that become delta N by only number of moles of gaseous product. This is relation. Next, X or alpha proportional to or X proportional to what? 1 by P power delta N by NP, delta N by NP. What does it mean? Number of moles of reactant molecule dissociated is inversely proportional to pressure power delta N, number of moles of gaseous product minus number of moles of gaseous reactant by only number of moles of gaseous product. So here, to explain effect of volume to effect of pressure on dissociation, degree of dissociation, what is the factor? Delta N. That means the effect of pressure, pressure and volume. Pressure is partial pressure and volume on X, number of molecules dissociated, depends on delta N and NP of that equilibrium reaction. The effect of volume and partial pressure on number of molecules dissociated depends on delta N and NP of that equilibrium reaction. So delta N depends on mainly delta N. So delta N in three cases. Case 1, if you see case 1, delta N is equal to, delta N is actually delta Gn is equal to 0. Delta Gn is equal to 0. For example, H2 gas plus I2 gas gives rise to 2HI. H2 gas plus I2 gas gives rise to 2HI. This is my equilibrium reaction for which delta N is equal to 0. Then what you can say? What is the volume effect? effect of volume on degree of dissociation. Degree of dissociation or number of moles of molecules dissociated x proportional to V power delta n by Np. For this reaction, what is delta n? Delta n is equal to 0. Np is equal to only number of moles of gaseous product is 2. So it become what? X proportional to V power 0 by 2. That is what? X proportional to V power 0. X is equal to what you can say? Constant. Ante when volume increased or decreased, X doesn't change. If delta n is equal to 0 for equilibrium reaction, then by the increase of volume, X constant and number of moles of molecules dissociated constant doesn't change. So next, pressure effect, partial pressure effect of partial pressure. Then X proportional to number of moles of reactant molecule dissociated proportional to 1 by P power delta n by Np. So here X proportional to 1 by P power, what is the delta n? 0 by 2. That is equal to what? X power P, X proportional to P power 0. That means something power 0 is equal to 1, 1 is constant. So X remains same. Number of moles of reactant molecules dissociated remains same. That doesn't depend on partial pressure also. Okay. Next, addition of inert gas. Addition of inert gas. Inert gas do not react with reactant molecules or product, but what happens? Total number of gaseous molecules increases, total pressure increases. This is concept. Okay. So addition of inert gas in two conditions. Entavi at constant pressure. Addition of inert gas at constant pressure. Whenever inert gas is added at constant pressure, what happens? Pressure constant means volume definitely increases. So by the addition of inert gas at constant pressure, what happens? Volume increases. When volume increases, what you can say? X doesn't depends on volume, So X is equal to what? Constant. X is equal to constant. And X remains same. Of course, volume increases by the addition of inert gas to equilibrium reaction at constant pressure. Volume increases but X doesn't change. Next, if condition at constant volume, addition of inert gas to equilibrium reaction at constant volume, then what happens? Total pressure increases. Partial pressure doesn't change, but only total pressure increases. The total pressure increases, but partial pressure is no change. Partial pressure is constant. Then X is also constant. Okay. So by the addition of inert gas to equilibrium reaction at constant volume, X constant, X do not. Okay. Addition of inert gas at constant volume and temperature, X constant, already discussed. Next, case 2. This is case 1. Here delta n is equal to what? 0. Now case 2, delta n is negative. Case 2, delta n is 0. If delta n is negative, means less than 0. Delta n is negative. In this case, what is effect of volume, pressure, addition of inert gas on equilibrium reaction? For this case, example is what? Example is delta N negative mean N2 gas plus 3H2 gas gives rise to 2NH3 gas. 2NH3 gas. For this reaction, delta N is equal to number of moles of gaseous product is 2, number of moles of gaseous reactant 1 plus 3, 4. 2 minus 4, that is equal to what? Delta N is equal to minus 2. And Np is equal to what? Np is equal to 2. Now for this type of reaction, see effect of pressure, effect of volume on degree of dissociation alpha. So for this, effect of volume. For this effect of volume, X, number of moles of reactant molecule dissociated, proportional to V power delta N by Np. It implies X proportional to V power what? Minus 2 by 2, that is V proportional, X proportional to V power minus 1, that implies X inversely proportional to volume. What does it mean? When volume increases for this type of reaction, number of reactant molecules dissociated will decrease. Next, effect of pressure. Effect of pressure. What is the effect of pressure? X proportional to 1 by P power delta N by Np kada. So for this reaction, delta N is equal to what? For this reaction, delta N is equal to minus 2 and Np is equal to what? 2. So X proportional to 1 by P power minus 2 by 2, that is equal to minus 1. X proportional to 1 by P power minus 1, that is X proportional to M avutadi, P avutadi. So it means when partial pressure, this is partial, when partial pressure of reactant molecules increases, degree of dissociation increases. For this type of reaction, whenever delta N is negative, when partial pressure of reactant increases, number of moles of reactant molecules dissociated will also increases. Next, third one, addition of inert gas to this kind of reaction. Addition of inert gas. In this two condition, at constant pressure. By the addition of inert gas at constant pressure, what happens? Volume definitely increases. When volume increases, what is the relation between volume and X? X decreases. So number of reactant molecules decreasing, number of moles of reacting molecules dissociated will decrease. This is the effect. If addition of inert gas takes place at constant volume, so దీనికి బిగినింగ్లో చెప్పిన కండిషన్, at constant volume and temperature, total pressure increases, but partial pressure doesn't change. Whenever partial pressure doesn't change, X also constant. Okay, here two cases completed. What is case 1? See, if delta N is equal to 0. What is case 2? Case 2 is if delta N is negative. Now what is case 3? We need to consider delta N is positive. Case 3, delta N is positive, or delta n is greater than 0. For this type of reaction, example, PCl5 dissociate phosphorus pentachloride gas dissociate to give PCl3 gas plus Cl2 gas. For this type of reaction, what is the delta n? Delta n is equal to number of moles of gaseous products are 2 here, and the number of moles of gaseous reactant is 1 here. 2 minus 1, that is equal to delta Gn is equal to what? 1. That means positive. And what is the Np for this reaction? Np for this reaction is 2. Number of moles of gaseous product are 2. Now see effect of volume. Effect of volume on this type of equilibrium reaction. I mean delta n positive for this type of reaction. Okay. Then it become, if what is x? X proportional to v power delta n by np. So for this, x proportional to what? V power. What is the delta n? Delta n is equal to 1 by what is the np? Np is equal to 2. That means what does it mean? X proportional to root v. That means when v increases, when volume of the reaction increases, when volume increases, number of moles of reactant molecules dissociated also increases. Okay. Next, effect of pressure. Effect of pressure. So x proportional to what? X proportional to 1 by p power delta n by np. That means x proportional to 1 by p power. What is the delta n for this reaction? Delta n for this reaction is what? Delta n for this reaction is 1. Np is equal to 2. So 1 by 2. What does it mean? X proportional to 1 by root p అవుతుంది. అంటే when partial pressure of reactant increases, only P రాస్తేనేమో partial pressure, PT రాస్తేనేమో total pressure. When partial pressure of reactant increases, then number of moles of reactant molecules dissociated will decreases. Next, addition of inert gas. Addition of inert gas. In these two conditions, at constant pressure. Addition of inert gas at constant pressure అంటే మనం వాల్యూమ్ ఇంక్రీజెస్ అనమాట. వాల్యూమ్ ఇంక్రీజ్ అయితే వాట్ ఈస్ ది ఎఫెక్ట్ ఆఫ్ వాల్యూమ్ ఆన్ ఎక్స్? వెన్ వాల్యూమ్ ఇంక్రీజెస్ ఎక్స్ ఆల్సో ఇంక్రీజెస్. అంటే బై ది ఎడిషన్ ఆఫ్ ఇనర్ట్ గ్యాస్ ఎట్ కాన్స్టెంట్ ప్రెషర్, degree of dissociation increases. Number of molecules dissociated will increase. Addition of inert gas at constant volume. By the addition of inert gas at constant volume, for all kind of reaction, X remains same. By the addition of inert gas at constant volume, what happens? Total pressure increases, but total pressure do not show any effect on X. Only partial pressure will show effect on X. So X remains same. X is equal to what? Constant. X become constant. So మీరు ఒకసారి చూడండి. 3 types of reactions లో, if delta n is equal to 0 condition, delta n is equal to positive condition, and delta n is equal to what? 0 condition. Delta n is equal to negative condition. ఈ మూడిట్లో ఫస్ట్ కేస్ 1 delta n is equal to 0 అయితే when volume increases or pressure increases or volume decreases, pressure decreases, x is constant. x కాన్స్టెంట్గా ఉంది. నెక్స్ట్ డెల్టా ఎన్ ఈజ్ ఈక్వల్ టు పాజిటివ్ అయితే, ఇఫ్ డెల్టా ఎన్ ఈజ్ ఈక్వల్ టు పాజిటివ్, if delta n is equal to positive, in this case volume increases, x increases, pressure increases, x decreases. So what you can say, volume increases, then what happen, x increases, when pressure increases, x decreases, when pressure increases, x decreases. If delta n is equal to negative, in such cases when volume increases, x decreases, when pressure increases, x increases. See this, volume increase, x decrease, pressure increase, x increase. So where is that, this one, when volume increases, x decreases, when pressure increases, x increases. So this is very important, we need to understand this concept. Okay, next, addition of inert gas. Shortcut, addition of inert gas. Addition of inert gas, addition of inert gas at constant volume and temperature, x remains same. Addition of inert gas at constant pressure దగ్గర మాత్రం it depends on addition, x depends on what, delta n. This is final conclusion from all the three cases. So what we have discussed, factors affecting degree of dissociation or factor affecting x. డిగ్రీ ఆఫ్ డిసోసియేషన్ ఎఫెక్ట్ చేసే ఫ్యాక్టర్స్ అన్నా లేదా నెంబర్ ఆఫ్ మోల్స్ ఆఫ్ మాలిక్యూల్స్ డిసోసియేటెడ్ అన్న సేమ్ అవుతుంది, బికాజ్ ప్రపోర్షనాలిటీ అని చెప్తున్నాం కదా, రైట్. నెక్స్ట్ వన్ ఈజ్ రిలేషన్ బిట్వీన్ డెల్టా జీ నాట్ అండ్ కే. what is the relation? Delta G is equal to, from thermodynamics, delta G naught plus RT ln K. K is equilibrium constant. So at equilibrium state, this is Q, from thermodynamics, Q. What is Q? Q is reaction quotient. Q is what? Reaction quotient. Q is reaction quotient. So at equilibrium, delta G is equals to 0 and Q is equals to K. సో స్మాల్ కాన్సెప్ట్ Q ముందే చెప్తే బాగుండేది, బట్ ఇక్కడ చూసుకోండి. కన్సిడర్ ఏ ఈక్విలిబ్రియం రియాక్షన్ A plus B gives rise to C plus D. For this reaction, it is just reversible. Consider it is just reversible reaction, not present at just reversible reaction, not present at equilibrium state. Even though reaction not present at equilibrium state, we can write Q. What is Q? It is C molar concentration of product of molar concentration of product by product of molar concentration of reactant. We can write Q for any reversible reaction which is not even present at equilibrium state. If reaction present at equilibrium state, this reversible reaction present at equilibrium state, then what happened? Q is equal to what? K. Ante K is equal to what? If reaction present at equilibrium state, molar product of molar concentration of product by product of molar concentration of reactant. What does it mean? Both equilibrium constant K and reaction quotient Q appears to be same. Only the difference is we write equilibrium constant K only for reversible reaction present at equilibrium state. Only present at equilibrium state. And we write reaction quotient for reversible reaction at any state other than equilibrium state. For all condition we write Q. If reversible reaction present at equilibrium state, then we write K. Reaction not present at equilibrium state, we write Q. Reaction present at equilibrium state, we write K for reversible reaction. Hope you understood. So whenever delta G is equal to 0 and Q is equal to K, what you can write? 0 is equal to delta G naught plus RT ln Q become K. From that, delta G naught is equals to minus RT ln K. Minus RT ln K. So since ln is what? Base E, that is equal to 2.303 log base 10. So what you can write? Delta G naught is equals to minus 2.303 RT log K. This is the relation between delta G naught and K. Or you can also write like this. Both are same. Hope you understood. This is about relation between delta G naught and K. Standard Gibbs energy change of equilibrium reaction and equilibrium constant K. This is our third topic. And second one is what? What is second one? Degree of dissociation and factors affecting degree of dissociation. Second topic is what? Degree of dissociation and what? Factors affecting on degree of dissociation. So you need to remember this one, last shortcut table, this one. This is very, very important. So this one and this one. And what is first topic we have discussed? That is applications of equilibrium constant. Applications of equilibrium constant. Applications of equilibrium constant. Only simple thing, when K value increases, stability of product increases, but stability of reactant decreases. Because K is equal to what? K is equal to general గా ఏం రాస్తాం మనం? Product concentration by reactant concentration. దీని నుంచి గుర్తుంచుకోండి, when K increases, stability of product increases. Stability, this is stability. When K increases, reactant stability decreases. Hope you understood. Thanks for watching this video.